My name is Raul Rodriguez, and this is our NASA Big Idea Challenge 2020. So, permanently shadowed regions of the moon are located on the north and south pole of the moon, and scientists believe that there's actually water that can be extracted from these locations in the form of ice, since temperatures range from negative 450 degrees Fahrenheit to 334. The way this occurs is when a meteor strikes the moon containing water in the form of ice, it is actually spread throughout the surface of the moon. While most of it does end up evaporating, there's some that actually remains and gets trapped in these permanently shadowed regions, and due to the very extreme temperatures, it ends up staying there in the form of ice, which can then be extracted, which scientists believe we can do. The following image shows a representation of what we so far have obtained as far as information goes of water locations in the moon. We have only sent spacecrafts which use radio waves in order to see the lightness of certain areas, which basically predicts where this water in the form of ice would actually be located. Here's another image, and as you can tell, these are how the regions will look. There are permanently shadowed PSRs. Our team has developed a rover called the Vector 31721. So a good method used to extract substance from materials such as soil is by using heat. Solar heating is not an option in this case due to the lack of sun's energy in these locations. As an alternative method, our team has proposed the use of microwaves. So we're gonna have a plate underneath the Vector, and the way it's gonna work is the microwaves will extract the water ice located in the material, which will then be stuck to the top of the plate and can be scraped off later on. So, storing the ice. Using a microwave to have the ice melt and rise to one of many plates which could have their own storage container as to not lose what has been gathered. The climate control storage only is needed when it is lunar day, as the heat from the sun will be about 106 degrees Celsius and melt the ice stored. So if it can be kept at about negative 50 degrees Celsius with a constant stream of energy from the solar cells, all will be okay. The solar cells will be provided through solar panels, so the solar energy is going to charge a battery, which we'll get to that point later on. Climate control at night is not needed, as it will be negative 183 degrees Celsius, and thus the ice will be frozen regardless. So this is how our rover will be charged. It will have a continuous track system, so think about a tank with a belt around the wheels. It will have a lithium-ion battery that holds 38 watts per hour, solar panels with 11 watts at 28 degrees north, and it will consume 4.5 watts while in idle and 21.5 watts while moving across terrain. The lasers that will examine and explore the PSRs, they will be terrestrial laser scannings, which are used in construction very commonly in order to determine how much water is in materials and different construction materials. It also looks for color, roughness, and that kind of stuff, and moisture in the soil. So this is what we will use in order to detect where the water in form of ice will be located in the PSRs. So this is one of the models that we created for our rover. So as you can tell, this is the bottom view. Right here is going to be, in the middle, is going to be the plate along the edges and the corners where the microwaves will actually come out. And in the middle is where the water will actually stick in the form of ice, which will be stored or can be scraped off as whenever the rover comes out of the permanently shadowed regions. Here is another images of what our model will look from different angles. As you can tell, at the top here is the laser, the terrestrial laser that will be used in order to find out where exactly the water is located in the region. And then we have the wheels, which, like I mentioned previously, are going to be a continuous track system. Sorry about that. And at the top here are the solar panels, and inside this rover will be the battery, where the battery will be located. So the sun the sun's energy will actually be tracked by the solar panels located right there at the top of the rover, and which would then be converted into energy for the battery.